everyone, today I'm going to solve two examples on domain and the inverse of a function, and both examples are coming from the Stanford University. So let's look at the first example here. We have f of x equals to ln of x over x minus 3, and we want to find the domain and the inverse of this function. So let's see what is the first part and how we can find the domain of this function. As you might remember, for the domain of the function, we have to find the x, or actually the domain in which the function is defined. And here we have f of x equals to ln x over x minus 3, and we need to see for which cases or for which x this function is defined. And if we look at this function easily, we can say, okay, if we plug in x equals to 3, this is going to be undefined. Therefore, x equals to 3 is not inside the domain. So x cannot be 3. So this is the first thing that we can understand from this function. The second thing, when the natural log is defined, in fact, when we plug in a positive number inside the natural log, it is going to be defined. Therefore, the fraction of x over x minus 3 should be always positive. And from here we can say, okay, x over x minus 3 should be always positive. And from there we would have two cases. The first case, x and x minus 3, the denominator and numerator, both should be positive, or the denominator and numerator both should be negative. Therefore, we can say the first case, if x bigger than 0, therefore x minus 3 should be bigger than 0, and from there we can say, okay, x should be bigger than 3. And the second case, if x is less than 0, therefore x minus 3 should be less than 0, which means that x is less than 0. Now we have the domain for both of cases, and it's time to combine them. And from the combination of these two, we can say, okay, the domain is going to be from minus infinity to 0, and 0 is not inside it, because if we plug in 0 in here, this ln is going to be undefined. And the second part is going to be 3 to infinity, and again 3 is not inside. If we put it inside it, it's going to be undefined. Okay, this is the domain of this function. Let's look at the second part, in which the problem is asking for the inverse of the function. And if you might remember, for the inverse of the function, we have to follow a few steps, and here we are going to use those steps again. So the first step, instead of f of x, we should write y. So it's going to be y equals to ln x over x minus 3. This is the first step that we have. So once we have this step in here, it's time to swap y and x. Therefore, we can write this function as x equals to ln y over y minus 3. And after that, it's time to use the definition, some rules in log and some rules in natural log, basically. So what we can do is we use x and ln as the power of number e. Therefore, we can say, okay, e to the power of x from this side, and e to the power of, like, e to the power of x and e to the power of ln y over y minus 3 is going to be e to the power of x equals to, let me erase this, so it's going to be y over y minus 3. So why we have y over y minus 3? We just use this rule. E to the power of ln of x is equal to x. and we just use that in here. So e to the power of x equals to y over y minus 3, and now it's time to rearrange everything based on y, and then we have the inverse of the function ready. So it's going to be y minus 3 times e to the power of x equals to y, and from there we can say, okay, it's going to be y e to the power of x minus 3 e to the power of x equals to y, and then we can write, okay, this is y e to the power of x minus 1 equals to 3 e to the power of x, and from here we can say, okay, y is 3 e to the power of x e to the power of x minus 1, and y is basically f inverse of x, and from there we can say, okay, this is 3 times e to the power of x e to the power of x minus 1. So as we have seen, we just followed a few steps, a few basic steps, and finally we got the inverse of the function. Even though the function was looking a little bit complex, but we just used a few basic rules inside the natural log and we obtained the inverse of this function. Let's look at the second example in here, and we want to find the inverse of this function this time, just the inverse. And again, we have to follow the same steps that we have seen for the previous problem. And from there, we would have y, the first step, instead of f of x, we plug in y, and it's going to be 1 over 1 plus e to the power of 1 over x. And the second step from here, we just need to swap y and x, and therefore it's going to be x equals to 1 over 1 plus e to the power of 1 over y, and then we can just use the inverse of that. It's going to be 1 over x equals to 1 plus e to the power of 1 over y, and from there it's time to take the basically the natural log from both sides. So we can write 1 over x minus 1 equals to e to the power of 1 over y, and taking the natural log from both sides here, ln and ln, would give us ln of 1 over x, ln of 1 over x minus 1, and the other side is going to be 1 over y. And the aim is to find y, therefore it's going to be 1 over natural log of 1 over x minus 1 equals to y, and basically this y is the inverse of the function, and the final answer in here is going to be f inverse of x equals to 1 over natural log of 1 over x minus 1. Hope you enjoyed watching this video. As we have seen, finding the inverse of the function and finding the domain of the function is not complex. We just need to follow the definition for the domain, and we just need to follow a few steps. And if you want to review those steps, you can watch our previous video on the inverse of a function, and from there you can find the inverse of any functions that you are dealing with based on your knowledge in calculus. So don't worry, inverse of a function is not complex, just a few straightforward steps. Again, thank you very much for watching this video. If you enjoyed and learned how to find the inverse and the domain of a function, please subscribe our channel.